So the other day, a data scientist from Harvard, Kareem Carr, stats PhD student, I tweet about data science, what it is, how to do it better, and why it matters. Kareem Carr tweeted a proof, oh, we got a thunderstorm here, a proof that 0.9 recurring is equal to 1. And I commented on it with something that I've seen quite a bit in my tutoring, because we cover this a little bit at GCSE. So for example, 1/9, you can calculate this using the bus stop method, is equal to 0.1 recurring. And then you find 2/9, that's equal to 0.2 recurring. And 3/9, well, that's a third. And we can see that that's 0.3 recurring. And there's a pattern. And the pattern is real. Some patterns in maths, they look right and then they fall down later on. But this one, let's do 6/9, that's 2/3, and that's 0.6 recurring. And let's just do another random one like 7/9. That turns out to be 0.7 recurring. So 9/9, which is obviously equal to 1, is also equal to 0.9 recurring, just following the pattern. 1 is 0.1 recurring, 7 is 0.7. So 9/9, that's equal to 1, but it's also equal to 0.9 recurring. Kareem's proof was more around thinking about what's the difference between, so if you do 1 minus 0.99999, and you actually write that out forever, then what are you taking away from 1? Well, that last digit that you take away from 1 is so tiny, is so negligible, that you actually end up with 1 minus 0.9 recurring equals 0, or 1 equals 0.9 recurring. But I was thinking about this yesterday, and I was driving along, and I remembered I was looking at, you have this where you have a geometric series. So geometric series, the sum of a geometric series, a plus ar plus ar squared plus ar cubed plus like that forever. If -1 is less than r is less than 1, then this sum, even if the series is infinite, has an infinite number of terms, the sum will be finite. And actually you can do quite a cool thing. If we write s equals a plus ar squared plus ... then we can write that s times r, well, we times each of these by r, so we get ar plus ar squared plus ar cubed plus ... And then if we do s minus sr, we end up with this minus this. The ar's cancel, the ar squareds cancel, the ar cubes cancel, like this forever. And we end up with just the only thing left over is the a. And then all we've got to do is factorize the s outside. We get s times 1 minus r equals a. The sum of this sequence is equal to a over 1 minus r. So let's think about that in terms of 0.9 recurring. So 0.9 recurring is 0.9 plus 0.09 plus 0.009 plus 0.09. Oops. You know what I mean. And then that is 0.9 plus 0.9 times 1/10 plus 0.9 times 100th plus 0.9 times 1,000th, and so on. So let's think about this. The first term of this geometric series is a equals 0.9, and the common ratio is 1/10. The sum of an infinite geometric is a over 1 minus r. So that's 0.9 over 1 minus 1/10, or 9/10 over 1 minus 1/10, or 9/10 over 9/10, which is 1. QED. We did it.
I did everything right and they indicted me.